Hello there, dear YouTubers. My name is Mr. Colorless King, and I am also the owner of the YouTube channel called KING1993 Gaming. So, without further ado, let's get started. And today I will be talking about one of the dimensional model in my CKDM. And today's topic will be about the which one was it? About positive 8 dimension. Okay. So, so the question is, what is the positive 8 dimension in the CKDM model. Before starting, we must need to confirm few of the important things that you must need to understand. That is, if you want to know what the CKDM is, if just go to my KING1993 gaming channel, and then as you go to the colorless king dimensional model, you will see list. Okay, list from -4 3 2 1 0 1 2 3. Okay, I think this is the second part. Anyway, 1, 2, 3, 4, 5, 6, 7. Up to 7 was uploaded. Now today I will be talking about the 8. Okay, 8. Okay, so what is 8? So without further ado, let's get started. So the thing about 8 is I have already talked about uh, parallel path processing in the plus 70. Okay, plus 70. I talked about parallel path processing. What was parallel path processing? In order to understand that, let me give you a demonstration first. Okay, so here's the thing. Alpha Phoenix is a YouTuber who made a video regarding how electron follow the path of least resistance. If it is true, then there is no reason for this thing to happen. Okay, what are these are basically points where electrons, when they flow from positive to negative or negative to positive, whichever they go from the path of least resistance. If that is true, then why can we see a bump here? Okay, why can we see that? Why is it going to the main route and also going to the side route also? It is an important topic. Why is it an important topic? Because when this YouTuber made this topic, we are forgetting some of the very important thing. And some of the among those some of the important topic is, if we were to take a topic, okay, let's say, where does the electron likes to go? Electron likes to go in a certain path, and the certain path is directly determined on which path they wish to follow. They follow the path of least resistance is what the mathematicians are saying, not the scientists themselves. Okay, and here we see Nikola Tesla is basically sitting in a chair of plasma arc, where he knew where the electron goes, and he was sitting there because he knows that his body is not going to be attract the plasma arc. Okay, so there are certain type of materials that the electrons like to go. Okay, and if you just go and watch my 7D, I will you will eventually understand. You just go and watch my video here. Other than that, let me explain here again. Okay, let's say this is a maze. Okay, and here are multiple path, and all of this path have a certain opening route. Now one might say, okay, which path does the electron go? Here is the simple topic. The electron, we thought, would go something like this, right? Wrong. This is the wrong answer. Electron will go here, and here also, here also, here also, this place. uh, this will, some will enter from this place, and some will enter from this to there, here, and there, and there, and will eventually go this place. Some will go to even this place. Like, they are gonna get in every place. The electron will go in every place. Why would the electron do that? That is the question. That is the exact reason why I am showing this image to you. Because if I do not show you this image, then what will happen is you will think that the electron follows the path of least resistance. No, they see every path and see in which path the electron is able to go easily, and that is the place where we can see the maximum brightness. Okay, so this is the exact thing. So This is what an indication is. Let's say this is a mark, and electron is following. And what is this mark? This is the mark of, let's say, an atom. So atom has a certain limit of how much vibration they can take before they can give the excess vibration out to another atom. Okay, and the path of least resistance, which we call, is basically like the atom is very efficient. As a result, what will happen is it will fill up another atom nearby, and eventually the electron will go to this place. Okay, and then once this gets full, it will bounce to another atom. So this is how, if there are many atoms nearby side by side, then what will happen is electron will move to this one, and then we would think that since this is the minus and this is the plus, electron will go from here to there, right, directly, right? No, it would go here, it would go here, and then some will go there, and most of them will go there, and which is why these two are not gonna get that much energy, but they are still going to receive some sort of energy. So this is parallel path processing, that electron is basically a signal. Okay, and in the plus 7D, the electron will go not in only one path, in multiple path. Okay, and how I also said lightning and fire are basically the same thing. They are basically a vibrational data. Let's say this is wood, we add fire to it, and this is metal, and this is electron. Electron is basically indicate how much fire, how much vibrational energy is detected in the fire, and how much vibrational energy is detected in the lightning. Okay, so the question is, what would happen if a lightning were to fall here in the wood? The wood will start into a fire. But what would happen if the lightning were to fall in the metal? Then the metal would just absorb the energy. Okay, now what would happen if we use a relatively safe amount of fire on the wood? The wood will still get burned, and what will happen if we apply the amount of energy that will make the metal warm? It will only stay warm, it will not get turned into fire. So why is the fire goes up and the lightning comes down? Fire goes up when it interacts with wood is because the wood has many gas type of material with some solid material. As a result, they will go up in the sky. Okay, whereas if we apply fire or lightning both to the metal at very high density, then what will happen is they will melt. Okay, they will melt, the metal will melt and will go down. Okay, why? Because of density. So what is gravity? People will say people will say what the heck, people will say gravity pulls everything. Gravity pulls everything. Well, uh, it is true and false, because Einstein took the formula of Maxwell equation to try to explain a gravitational wave, and Einstein only included the gravitational spark using Newtonian mechanic. How is this gonna work? Einstein took the formula of uh, electromagnetism of Maxwell equation, which is purely quantum, and then turned into a gravitational wave and say this is pure uh, gravity, only pulls, nothing push. This is wrong. This is the exact reason why I am saying that there is something wrong. Okay, and this my plus 8D will try to explain it. Okay, how? Allow me to explain. So the first thing that is, you can go to my website, but my website is not ready, sorry about that. You can just go and watch my video, and then you will be able to understand anything, everything. And this is the website. If you go to this website, Mr. Colorless King, sorry, Mohammed Salam Fursira, that is my legal name. If you click on it here, I will put it in the description, I guess. Then you will be able to see what my papers are. So you might want to start with the oldest one. The oldest one is -4 dimension, and the newest one is positive 7 dimension. Up to positive 7 has been uploaded. You can download it from Zenodo. Okay, like if I were to do this, Muhammad Salman Farsi Rahat, nothing shows up. But if I were to uh, click on it, only then shows up. So it means that I have no other choice but to provide the uh, link in the description. I will do that, don't worry about it. Okay, now here's the thing. I already uploaded my topic here, and then I told it, okay, give me all of the correction, sorry, not all of the main topic. Okay, so what is parallel path processing? I already said, just go watch my video. And as for the average definition of path averaging, it is basically like the 8 dimension is defined not as a spatial coordination but meta coordinate description of the process of myriad quantum scale interacting pathways converge into a stable macroscopic phenomenon. It is the organization principle that resolves the microscopic uncertainty to deterministic macroscopic behavior. So here is the thing. Let me drink some water. So here's the thing. Imagine you have a magnet. One side is S, another side is N. Now imagine you have 10 trillion, or let's say, yeah, let's say we have about 10 trillion of them. 10 trillion of them. Now we have 10 trillion of what? A ground. Okay, now imagine this is the carpet. I'm gonna make it even less so it looks like a carpet. So now imagine there is a ball here. Okay, now the question is, what will happen? Will the ball fall? The answer is the ball will fall. But if we zoom in on the ball, ZOOM, zoom. If we zoom in on the ball, then we will see the same effect as before. What? That it has S and N. Okay, it has S and N. So N pull, and sorry, N same pole uh, reflect, and opposite pole attract. Okay, so the question is, if this is true, then obviously what happens is, if there are if at if atoms are electromagnetic by nature, then what will happen is, all of these trillion of atomic platform you see on the bottom, the atomic ball, the ball that is made of atom, will also have trillion of atoms attached to it, and then it, as it falls, it is basically like N is attracting the S of this ball, and the S of the ball is attracting to the N of the floor. So the N and the S of the ball is attracting to the opposite of this ground. Okay, because all of them has what? Magnetism. Okay, electromagnetism. So if at atomic scale all atoms are electromagnetic by nature, then why the heck gravity is not this? Because gravity is exactly this. And not only this, don't bullshit me. Okay, allow me to explain. Let's say this is the planet Earth, and this is the moon. Okay, MOON, moon. Now what do we see on the moon? We see that it rotates around the Earth. Okay, it rotates around the Earth, but not on its axis. It rotates on the side of the Earth while facing side the same side of the moon on the Earth continuously. It doesn't rotate. Okay, so the question is, why does it not rotate? Many people will say because it is moving at the same velocity. The concept of velocity came from the non-stop non-falling velocity idea actually came from Newton. So Newton said, if I could throw a cannonball very fast enough, let's say cannon see, this is a cannonball, is going to throw a ball. If he does it fast enough, then it will go and move around the earth once. Or if we do it with a very powerful cannon gun, then it will move around the earth continuously. The question is, will it or will it not? The answer is not, because if we do this, let's say hit the cannonball, then what will happen is eventually it will fall after one rotation. It will not rotate forever. So the question is, why is it rotating forever? Not because Newton idea that the the cannonball will never fall. No, that is not the main reason. The main reason is uh, of electromagnetism. Now one might think, okay, why am I saying gravity is electromagnetism? That is because electromagnetism is part of the nature. Einstein, as I already said, Einstein took the formula of electromagnetism of Maxwell equation to create the gravitational wave. Einstein used this formula to say gravitational wave is real, and yet deny and yet he denies that gravity shouldn't have a push. This is impractical. Okay, now if we say, okay, then what does this first one means? It means, as I already said, if there is a large magnet, not large magnet, let's say there is a atomic magnet, and each atomic magnet has S and N, and there are trillion of them, okay, are unlimited trillion of them. So what will happen is the ball that is on the sky will eventually get attracted to the N. The S part of the ball will get attracted to the N part of the ground, and the N part of the ball will get attracted to the S part of the ground, and eventually it will fall in the proper place. So there are many small and smaller N and S on the ground and on the ball also, which is why they get attracted. Now what will happen if in some places the density factor happens? Okay, for example, if we go and look at the uh, gravity uh, density data of the earth, we'll see the that in certain part of the earth, especially near the water area, in a certain part of the earth, especially near the water area, the density is the lowest. What density? Sorry, not density, I mean the gravity is the lowest, whereas in some other place the gravity is highest. The gravity is also highest in places where there are more masses. Okay, so this is basically what it looks like. So the question is, why does the earth looks like a sphere, but in the gravitational data it looks like this? Why does it look like this? That is because of another factor. Let me introduce the factor that is called uh, uh, gravimeter, mining gravimeter. Okay, so here is the thing. uh, industrial 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 gravimeter. Okay, so here's the thing. What is an industrial gravimeter? It is basically a machine, industrial gravimeter, okay, for mining. Industrial gravimeter for mining are highly sensitive specialized tools designed to detect, map, and monitor subsurface density variation to identify ore. Okay, so it is basically saying that this machine here this machine here is used to determine what type of mineral are hidden below the earth, so that the mining company can go there and mine, and it happens a lot. So the question is, why does it happen? So why does different atom show different reading? Okay, shouldn't the gravity or acceleration. How do we even measure gravity? This is the important thing. Okay, so here's the thing. When it comes to gravity, how do we measure gravity? Unlike magnetism, where basically if we can align the S and N, S/N part of the magnet properly, then what will happen is they will get attracted. And how do the attraction happen? By pulling each other together. Okay, now here is the thing. When it comes to gravity, what happened is we look at the acceleration of the falling object. So let's say this is the complicated machine that detects variable gravity of the earth to determine what type of mineral can be found in the ground. Okay, so if this machine, which is a gravity meter, scans the ground, it will detect what? Variable minerals. So industrial people are already using the accelerometer, of the Newtonian mechanic of acceleration to determine how much gravity there is and to determine what type of ore can be found. Ore can be found below the earth is a direct indication of why this is not incorrect. This is correct. Okay, so this is what they use. MEMS gravimeter for mineral exploration, SMG gravity. Okay, so this is basically future of mineral exploration with advanced gravimetry. So this is basically they use um, machine that basically detects an acceleration rate to determine what type of mineral can be found there. So this is an important topic, and I already showed you the map, gravity density gravity map of the Earth. So if the gravity map of the earth already shows the variable gravity rate of the earth, then who are we to say that gravity is basically a smooth stuff, stuff stuff that pulls, pulls, pulls only? This makes no sense, because Einstein says theoretically speaking, Newton and Einstein says that gravity are fixed, 9.8 meter per second. They are not going to be variable. Then why do we see variable? Okay, so if I were to say variable acceleration, variable acceleration of uh, gravi variable gravity acceleration of gravity variable by atoms. The acceleration of gravity is generally considered as 9.8 near the earth. However, it is not truly uniform. It is a variable based on local mass distribution, geological structure, altitude, latitude, and it hasn't written here, but it is also determined by atoms. Okay, so atom if every different atom, from I said from 1 to 82, are basically real atom, is what I said in my previous topic. If you do not understand, go and read my plus 6D. Okay, I said that atoms from 1 to 82 are real atom, afterwards are basically some sort of anomalous bonding. Anyway, other than that, if I would say that okay, after all of these atom, they have different density. So when we look for water will have less gravitational pull compared to iron. Okay, so why is this? This is because uh, the concept of gravitational pull and magnetism, both of them has one important thing. And what is this? They are both invisible. Invisible. Okay, we cannot detect them with quantum mechanic. We cannot detect them with quantum mechanic. The only way we can detect them is by the pull, P U double L, pull. So if something is getting pulled, we know either magnetism is happening, or if something is getting pulled on Earth, we know gravity is happening. But we cannot say if a gravitational field is happening or not based on the concept of detection. Because here is the thing: when I take a magnet, the SN, and let's say this is a copper. I am moving the copper left and right multiple times. What will happen? What will happen is the copper will get extremely heated. Why? Why will the copper get extremely heated? Because it is producing something called eddy current. Okay, when you move a metal besides a magnetic field, it will produce an electric field, and an electric field creates a magnetic field, and vice versa. So every time I am breaking the connection of the magnet in between by moving the copper back and forth, the copper is now getting what? It is gaining a vibrational energy. And when the copper is gaining a certain vibrational energy, this energy is then converted to electricity or electron. Okay, so this is how it goes. Now here is the thing: if this is the case, if we use an infrared camera, if we use the infrared camera, and if we look at the same thing, S and N, and if we look in between, what we will see using the infrared camera is we will see nothing here. We will see cold, nothing but cold, because there is nothing there. Okay, but if the moment I put a copper in between them and move it left and right, we'll see with the infrared camera that if this is the copper rod, this copper rod is gonna get heated. Okay, and this is true, it happens. How? Let's see, copper hitting with magnet, COPPER, copper hitting with magnet, so you will see many video, including this one, where you will see that a certain person will basically make the magnet move extremely fast, and then that will in turn causes heat production. Okay, so this is a real topic. It happens because I have already seen one of these. Okay, maybe not that one. Okay, maybe this one. So I have already seen this topic. It actually happens that when you basically break the magnetic field of the copper over and over again, you will eventually see that things will start to heat up, because a moving magnetic field creates an electric field, and when large quantity of electricity enters a copper, then eventually the copper will get heated. So if all of this is real, then what does it mean? It means the field the field of the magnet S and N, and they want to pull each other. This field you see here, these are thermodynamically invisible. Okay, it means their effects are real, but quantum mechanic wise we cannot detect them. The same thing happens with gravity also. Gravity also does this. Okay, let's say this is the Earth and I am here. Okay, not very far, let's say I'm very close to the Earth. Okay, I'm very small. What will happen is I am going to get pulled by the Earth, but nowhere will we be able to detect any type of uh, thermodynamic presence. We will not be able to detect them. The only thing we will be able to detect is the acceleration rate. Okay, we will see that if there is a spring, let's say this is a spring, we'll see that the spring will continuously stretch towards the Earth. Okay, So why does this happen? This happens because both gravity and magnetism, not electromagnetism, magnetism, are basically the same thing. And this is where I said the same thing again, that gravity is basically when magnetism is averaged out. How? If we take the idea of S and N, and there are trillion of them, and the ball is also S and N, then this S part will get attracted to here, and this N part will get attracted to here, and eventually attraction happen. This is how one atom attracts the other. Okay, now let's move on to the second topic, is quantum to classical transition. Okay, I already explained this. Okay, the magnet paradigm. uh, so here is the thing, this I already explained, but imagine you have 1 inch cube magnet. You have 1 inch, INCH, 1 inch cube magnet. Okay, what will happen is, if we actually zoom in properly, the amount of atom there will be is already going to be above trillion. Why? Why above 1 trillion? Because at the atomic scale, is so small that we have no other choice but to measure it not by individual atom. We have to measure by mass or weight or by volume. We have no other choice but to measure it with mass or weight or volume. So why is this? Because these are far easier to measure than measuring each individual atom. Okay, now electron shell saturation, this is the important part. Now when it comes to oxygen shell versus a hydrogen shell, hydrogen shell. Okay, so when we talk about why magnetism is stronger than gravity, why magnetism is stronger than gravity, the question is, magnetism is stronger than gravity because of the following reason. Okay, let me tell you one of this reason. Let's say this is an hydrogen, right? So in order to give a proper demonstration, let's assume, okay, that let's assume this is one hydrogen, right? And there is another hydrogen here. Okay, so there is two hydrogen. And how do we know? Because of this electron. Okay, what is an electron though? We have to be careful. I already said electron is a vibrational signal. We need to be careful of this part. Electron is a vibrational signal. And oxygen shell. Now let's look at the oxygen shell. It has two shell 1 and shell 2. In shell 2 there is 6, and in shell 1 there is 1, sorry, 2. So in this case, what I will do is make one here. Okay, and another small one here. Okay, 1, 2. So this is the first shell, and this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you might be asking, okay, what is this? This is H2O. Now careful when I say the following thing. So if I were to delete this, okay, not that way, let's say I'm just gonna mark them right now. So if I were to delete this and this, then it will become what? It will become only oxygen, and this will basically go away as hydrogen. So the question is, why is the electron falling into this place here? Okay, so the reason behind this is what I eventually understood. The reality has two type of signal. The reality has two type of signal. One atom has two type of signal. A push signal is basically the electron. Okay, this is the push signal. So if I say, I will put it here like this, red is electron, a push signal, and the black one, I will use the black one as pull, 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 because of the gravity of the black hole. The black part of the black hole is black because the push signal is missing there. So the atom there exists, but it cannot be, it doesn't reflect back. Okay, let's say this is a mirror. We see the reflection of the mirror because the vibrational energy, this is the vibrational energy of the skin, bounces off the mirror to our eyes, and as a result we can see our faces. Okay, but in the black hole, what happens in the black hole is, let's say this is a mirror, and the amount of non-vibrational energy, okay, I call this a non-vibrational energy, which is basically a pull, which is, which has no name. This is the thing, we call this magnetism. So in terms of magnetism, what will happen is, we, if we put our face in a mirror that is made out of black hole material, what will happen is, the lack of the vibrational energy of the mirror will basically makes our face will seem like it is completely dark, nothing is reflecting back. Okay, so in this way, when I say this black, it is pull, Pull, pull. Pull is basically a signal of the atom that is basically causes gravity and magnetism. And this is push, a push signal, P-U-S, is push, is a signal where it is not gravity, it is anti-gravity, and it is heat, not magnetic. Okay, so, or it is electron. Okay, electron. Okay, it is anti-gravity and electron. So the question is, what is happening in this case? When we talk about Maxwell equation, when we talk about Maxwell equation, we are basically detecting two signal at the same time, push and pull. But in a rod, let's say this is a copper rod, in a rod the amount of push pull has a variable rate. If the amount of P energy, or not P energy, P signal, or let's say vibrational energy, I will call this vibrational energy, if the amount of vibrational energy is much higher than the non-vibrational energy, as a result, if the amount of vibrational energy increases too much, then what will happen, this copper will melt. Okay, so if someone were to say, what does this all mean? Okay, what does this all mean? What does this shell saturation mean? The shell saturation means is when we talk about, let's say, the oxygen. Okay, 1 2 3 4, 1 2 3 4 5 6. So after all of this is done, the question is, if there are 6, 2 more are remaining, right? And in these 2 more cases, what we assume happens is, if we were to talk about these 2, right, these 2 area that need something where we will basically put one hydrogen, what is happening is that law of thermodynamic is happening. So what is the law of thermodynamic is heat, which is basically electron always move to a what, a magnetic field. Now you might be thinking, what the heck am I saying? Why magnetic field? Okay, some will say, no, this is not true. The electrons wants to enter the atom. Yes, the electrons wants to enter the atom, but what is it entering? It is a signal that is entering, right? Okay, so to give a more better intuition, in this case I will be using 2 different thing. I will be using a magnet here. Let's say not any type of magnet, like the type of magnet that only activates when I use the flow of electricity, and there is a metal pin here. Okay, metal pin, let's say, to hammer it down, that type of pin. This is not T, this is a pin. And let's say I have a torch light. Okay, a torch light, and it is throwing what? Electrons. So what will happen is, in this case, if I were to put the electricity here, then eventually the magnetic field will basically tell the atoms of this uh, pin to get attracted. It is creating a field. The field is causing this pin to get attracted to the magnet. And in this case here, let's say this is a very powerful torchlight, about 1 million lumen. So eventually what will happen is, if I were to get the energy on this pin, metal pin, the metal pin will get extremely heated. It might even melt. Okay, so what does this mean? It means in both of these two cases, people will use the following intuition, which is incorrect. People will say, but I can see the ray of light. You can see the ray of light because you are on a earth. You are on earth, and because you are on earth, you can see the ray of light because of the molecules on in the air. But we cannot see a pool, okay, even on the molecules on the air, which is why for magnet we see everything invisible, and for light we see some sort of visibility. But here's the thing: in the vacuum of space we cannot see any ray of light. We can see only two things. In the vacuum of space we can only see two things. That is, we can see the sun, which is the emission point, and the planets earth, which is the reflection point. So it is emitting light and reflecting back to the moon, etc. Or maybe the moon is receiving the energy from the sun and reflecting back to the earth during night sky. So what does this all mean? It all means that, let me drink some water, then I will talk. When my throat gets thirsty or dry up, I need to drink water, otherwise I cannot talk. In both of these two cases, if I would say, okay, why is the sun not falling into the earth, or why the moon, 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 is not falling to the earth, and why is the earth not falling to the sun? That is because of the averaging effect. Okay, what is the averaging effect? For example, when we talk about the sun, okay, the sun has an elliptical orbit, not straight. So what happens is, when the earth is in this place here, the amount of vibrational energy is so much high, the vibrational or push energy is so much high, that the earth, while it rotates, like the Curie motor effect, okay, which I created, the Curie motor effect, it is basically this one, where there is a strong magnet on the top and there is a metal holder, and this is the metal, a round metal, and I apply cold to the bottom and heat on the top. Eventually what will happen is, if my hypothesis is correct, this metal will start moving. Similarly, how that metal is moving, what will happen is, the reason the earth is following the sun but getting in this elliptical shape is because when the earth is constantly getting near the sun, I will basically use this one here. The sun is causing the vibrational energy or the push energy to tell the sun to tell the earth to get away, and eventually during the winter time it gets away. Okay, and then when it gets far enough, that the inverse square law starts to take effect, because the sun is a massive object and it is directing the light in many places. What will happen is, the due to the averaging effect, once it's go far enough, the earth is not getting affected. Eventually what will happen is, the earth is now going to get pull. Let's say the earth is here, it is now will have a pull effect. Okay, so my drawing is a little bit incorrect here. Let me draw it again. This is the sun, and the elliptical shape looks something like this. So this is basically the winter time, and this is basically the summer time. Okay, so in the summertime what will happen is, the sun will give much too much energy. to the earth, and then the earth will have no other choice but to move away from the sun. And as the earth is moving away from the sun, once the inverse square law starts to take effect, because the earth is now very far away from the sun, what will happen is both the sun and the earth will basically talk to each other, something like this, and then eventually they will come back, and eventually once they are very close enough, the sun will start to give extra energy again back to the earth in this way. And this is basically how we are getting the summer and the winter season. So what does the Curie motor effect indicate? The Curie motor effect indicates, this is a Curie motor effect. It is something that I have created. Colorless King Curie motor effect is, it is an indication that electromagnetism is something we never understood properly. Okay, we need to understand the field issue. So quantum field theory is, this is the quantum field theory, that my plus 1D is an indication of, say, where I said that what is an electron. Let's say this is an atom and this is another atom. Okay, plus 1D. So atom will send an electron. The electron will go straight until it interacts with an atom, and then it will either absorb the atom or refract or reflect. Okay, and because of this exact reason, we assume that electron is the only thing. But here is the thing, electron is not the only thing. Just like there is electron which is vibrational, which we are able to detect with the thermal detection camera, the electron has an opposite brother, and this is called magnetism, and it is not detectable by thermal detection camera. It is not detectable by thermal detection camera. And this is exactly what I am trying to say, that if the amount of ratio of the vibrational energy increases, then the Curie motor effect will start to take effect and the earth will start moving. Okay, and this is the exact reason why I am saying that the reason the, let's say this is the sun, and the elliptical path is like this, and during this path, when the sun is very near the earth, it basically receives large quantity of vibrational energy, telling the earth, go back, 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 until the inverse square law hits to the maximum amount. Then it will start to say, come back, come back, come back, come back, come back to me, come back to me, come back to me. When it is sufficiently close by, then again the sun and the earth, they both talk to each other, will say, get away from me, get away from me, get away, get away, get away, get away. And this is basically how the electromagnetism happens. So one might say, okay, what is vibration then? Okay, this is what is vibration then. I will talk about this later, but overall I was able to give you guys an idea of why basically electromagnetism is basically the same thing. So when I say, okay, I need to download this. Okay, let me download this. mm, and I one hydrogen one also. Hydrogen shell. Okay, here it is. Okay. Hmm. Open image in new tab. Okay, now I can download it. Okay. Okay, good, good, good. Okay, now let me load it here. So don't say, oh man, sorry about that. Okay, so here is the thing, I need to apply it in the following manner. Import to canvas from, okay, okay. So here is the thing, the reason the reason the hydrogen atom, okay, here is the thing. So the reason the hydrogen atom gets attached, control C, control V, and then the reason the hydrogen atom gets, why is it not rotating? The reason the hydrogen atom is getting attached to this area here is because the vibrational energy has the tendency to get stick or stuck with a non-vibrational energy zone. This is the law of thermodynamics. So when the vibrational energy, control C, control V, then what will happen is this two electron, this two hydrogen electron will basically say that I would like to get attached to a non-vibrational zone area, and I need to get attached to it immediately as possible. And because each atomic shell has a certain capacity limit with a maximum amount of something like 2, 8, 18, and 32. So in this case, if the material were to be something even heavier, which was going to be, let's say, at the third shell, and if it needed a lot more electron from other atomic material, then what will happen is they will try to attract those atoms. So after all of these electron shell are covered, okay, let's say the oxygen has a maximum of 2 electron shell and it overall creates what, H 2O, H2O. Then the question is, after the H2O magnetic components are done, what will happen afterward? Afterward, what will happen is, we assume, okay, after the magnetic effect of the water is done, it will be all right. No, after the magnetic effect of the water is done, what will happen is the water will still produce a residual, 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 a residual pull effect, pull, pull effect. And this is what dark matter is. Okay, this is what dark matter is. So one might say, okay, if, what the heck, this is dark matter? Yes, the thing is, the what we called uh, uh, dark matter, DARK, dark, MATTER, dark matter. What we called the dark matter is why the inner part of the galaxy is rotating as fast as the outer part of the galaxy. That is because the inner part of the galaxy is rotating at the same rate as the outer part of the galaxy, is because we assume that after the electromagnetic bonding of the electron is over, there will be no more electro bonding needed. If that is not needed, then the question is, why H2O plus another H2O makes, let's say, uh, a glass of water? Why does it make a GLA double S, a glass of water? Like, why are they staying in one place? They are already done. There is no need for them to stay together, right? But why do they stay together? They stay together because even after the electromagnetic work of the electron shells are done, they still produces the residual effect. And the amount of residual effect, the pull rate, that is the pull rate, remember, pull rate is the residual effect of the atom, are so much higher than we expect, that we actually have never accounted for the residual effect, and because of this reason, why we are seeing what we are seeing is the gravitational uh, dark matter effect. That why the galaxy inner part is basically rotating at the same part as the outer part of the galaxy. It doesn't make any sense because they did not account for the possibility of decoherence or coherence to decoherence, whatever they are called. I do not remember the proper topic. It is basically like how a quantum topic becomes a, a classical topic. This is what is happening. Okay, the quantum topic is basically the main thing, and the classical topic is the human intuition. So when we are mixing this classical topic with the human intuition, obviously we are not gonna get the proper outcome. We need more critical way of thinking of this thing. Okay, and this is where the dark matter concept will be gone if we think about the residual magnetic pole. Once we allow residual magnetic pole idea, only then the dark matter will be gone, otherwise it won't be gone. So one might say, okay, what about expansion of the universe? Okay, the expansion of the universe is a different topic that I will talk about it in the plus 12D and plus 13D of the effect of a vibrational and a non-vibrational effect of atoms in a, what should I call it, uh, red shifting versus blue shifting. It is a total mechanical data. It is a quantum data that comes from machine themselves. Machine interpretable data. That is what the red shifting and the blue shifting is. So if I were to explain it here, you will not be able to understand because a lot more topic are missing in the between. So I will stop it there. Okay, just think about it like that. So question is, how much true is this topic that I've said about the electron shell of the atoms? Okay, let's move on to the next part, then you will know. Shell, this is the shell topic, right? Now let's electromagnetic decoherence, which I already said. Okay, gravity as an emergent phenomenon, this I also explained. Measurement sensitivity disparity. Now in order to explain this one, I will talk about a specific topic here. So here it is. So there is another thing called the scale factor. For example, gravity, measuring gravity with milligram levitated masses. So basically speaking, what they did, they used a certain metal, and they used that certain metal to look for how much it was, and see how much it was able to produce a certain amount of atomic pool. Okay, I do not know where it was. My paper actually cited that it was about uh, 0.34. Here it is. We demonstrated the detection of 30 attonewton gravitational signal at 27 hertz damping line width as low as, I cannot read this, with a 0.0 0.43 milligram mass test. So what they did, they detected 0.43 milligram compared to 0.43 milligram to detect a neutron of 30 attonewton. Okay, so if we ask this topic, this topic, uh, 0.43 milligram has how many atoms? So what type of atom was it? It was something like uh, metal, some sort of metal. I forgot the name of the metal. What was the metal? Borosilicate or something like something. Uh, made of tantalum. Okay, this is the one. This is the one. So what is this? Neodymium magnet. Okay, I'm extremely sorry about that. So here's the thing. Neodymium magnet. So the question is uh 0.43 uh milligram milligram is how many atoms? Point. So this is the amount, and if we were to do the math, this is step 1, and then this is step 2, and then this is step 3. So the amount of uh, atom we expect is uh, 1.31 to the power uh, 10 to the power 18 is the amount of atom. So I still do not know what it is saying. So what I will be doing is I will be using Gemini. Yeah. Now I know this is a bit slow, like it is already 1 hour, but I need to explain it in my way as soon as possible. So bear with me, please. 0.43 uh, milligram of neodymium magnet of neodymium magnet has how many atoms? Okay, it is in pro version. I got this pro version for free, but I will be using it as much as possible. So it will be doing a certain calculation because it is a huge topic. So after the issue is done, I will get back to the, okay, let it load. So what does this is trying to say, or what does my paper is trying to say? So I actually got that data from this article, and then not article, like this research, and then I put the research in my paper also, and this is exactly what it was trying to say, of how many paths are basically come together to form this thing. Now when it comes to detection, the okay, so the amount of atom we can expect to be there is going to be 4.1 multiplied by 10 to the power 18 atoms. So if we were to compare it with an electron pool, okay, not electron pool, an electron push, then the question is how much push or how much small is it? Okay, so if I were to write it here, how big how big is this compared to the size of one electron? So what I'm doing is asking the question, like we can know how much strong one electron is. So if we compare one electron against this 0.43, which basically gives us the idea of 30 attonewton, then how much is it? Obviously the scale factor is going to be very high. So if we can detect each individual atom using the machine, which is vastly smaller than that, then the question is how much is it? The comparison of the radius of the magnet, which is 2.8 into 10 to the power negative 4 meter, to the classical electron radius 2.8 into 10 to the power 15 meter, the magnet is approximately uh, 85 billion times larger than the classical electron radius. So the 30 attonewton that we had detected is basically about 85 billion times bigger than an electron, and the machines are totally different type of machine. So when it comes to the machine, okay, so when it comes to the machine, we must need to understand some of the important topic, and that is when it comes to measuring measuring gravity. Okay, when it comes to measuring gravity, the acceleration and the rate of detection is much higher, about 85 billion times larger than detecting an electron. 85 billion times smaller. So this is the main reason why we cannot put, or why we cannot measure gravity, because when it comes to measuring gravity and electron, it is completely different way. So the reason we have not detected graviton is because graviton is not part of electromagnetism. No, gravity is part of magnetism. And what is electricity then? It is gravity. What does it do? We need to understand the gravity carefully. What does gravity do? It pulls. P-U-L-L-S, pulls. And what does the electron do? The electron sends signal. What does it do? It push. P-U-S-H, push. So this is the main difference. And the amount of push we need in order to make the magnetic field of any uh, materials to split apart is so much high that what we end up seeing is the dark matter part, D-A-R-K, M-A-T-T, dark, M-A-T-T-E-R, matter. We end up see dark matter, how the inside of the galaxy moves at the same rate as the outside of the galaxy. This is what we end up seeing, because the energy amount that is needed to destroy or to create a maximum entropy is much lower than the magnetic field. So in this case, what is happening, the reason dark matter, okay, not this, like this, the reason dark matter happens is because the amount of energy that is needed to uh, destroy matter is much lower. As a result, the magnetic field of the atoms over dominate the electric signal, the electron signal of the atom. So it is basically like something like, not even this, it is basically like this. Okay, so I would put something like this: the magnetic effect of the atom, is actually larger than the push energy, which is basically the electric part of the atom. So which is why dark matter happens. Otherwise, if this doesn't happen, what would happen is every galaxy would split apart. And this is the exact reason why the galaxy doesn't split apart, because the mass actually has more strength of pull than push. Okay, okay, shish. Okay, now let's move to the next part. Okay, uh environmental modulation of coherence, gravity, magnetic coherence, heat, the same thing. Okay, here it is, this one, vacuum cold welding. Now this is my favorite part. Okay, so vacuum welding. Okay, what do we know about the vacuum welding? So when it comes to the vacuum welding, now I already showed you about the uh, oxygen, like H2O, right? I already showed you this. But now here's the thing: what would happen if we take a large chunk of metal outside of the planet Earth? What will happen? Let's say this rate is an indication of air molecules. Once we take the metal outside of the earth, okay, what will happen? This will move away. All of this gas molecule will move away from the surface of the metal. Okay, and then what will happen is, once it gets contact with another metal, then they will attract each other, and then they will basically smoosh together, and this is why it happens. Okay, so can this be done on the on earth? Yes, it can be done on earth, because it has been done on earth, where uh, cold balding, cold, cold, bonding, HAPPNS, happens in lab. So cold balding was actually done in lab. Yes, cold bonding can happen in lab if we can get the excess amount of gaseous molecules out of the metal itself, then obviously cold bonding will happen. So this is cold bonding, right? Now the important thing about the cold bonding is, if we go back to my paper, that is, where is it? Like, here it is. If we go back to my paper, the reason gravity has a lot to do with cold bonding is because gravity has a certain problem. Not in a bad way, like we didn't understood it properly. Gravity is a sorting mechanism, which my 10D will explain. And because of the sorting mechanism, let's say this is the ground of the earth. Okay, this is the ground. This is the one layer of the air, another layer, another layer. So there are multiple layers. So on the topmost layer there is helium and hydrogen. Helium and hydrogen. As we go down, the amount of heavy air or heavy molecule increases, and this heavy molecule also interact with the metals. And because metals, let's say iron, if we can look at the iron ring, iron shell. So if we look at the iron shell, what can we see? We know how much each shell can take: 2, 8, 18, 32. So in this area here, in the 2 area, how many are missing? 32. About 30 is missing, right? And not only that, in this area here, in the inside area, there are uh, how many? 4 are missing. So obviously, in order to fill this up, what will happen is, as much as different type of gas type of molecule that exist, they will get attached to this. Okay, because if they have an imbalance with their atomic not atomic shell, like the electron shell, then they will get attached to it. Okay, so what is the electron shell? Electron shell is basically saying of how much vibrational energy there is, and whenever there is a vibrational energy, the vibrational energy of the other atom will try to enter the non-vibrational zone of the another atom, and eventually what will happen, they will try to stick together. Okay, and because the fourth shell of the iron has one about 2 electron detection maximum, signal detection, that is, which was detected in the vibrational mechanism of the devices, which basically counts how much electron shell can be detected in the different type of atoms. So eventually what will happen is, rest of the other iron that also have 2 electrons, they will stick to each other. Okay, this is a organized way of doing it, and they are actually not organized. So an iron will have multiple other iron attached to it, and at the end of the day, let's say let's say the amount of iron let's say the amount of iron atoms are basically covered by each other. Okay, and then there are none left. Then what will happen on the ground of the earth, that is, oxygen will basically stick together. Yeah, and oxygen is a type of atom that has a large quantity on where we live, and as a result we can see a large quantity of them. But in the vacuum of earth, like light like right outside of the earth, if we take the metal outside of the earth, then what will happen is, the oxygen molecule, let's say this is the oxygen molecule, will try to return to the earth, because it has a certain property of staying together in something that has more pull than the smaller one. So in this case what happens is, when the metal is basically outside of the planet earth, it basically loses its gas molecule, and the gas molecule basically enters back to the earth. And then once this happens, the metal will now have the, what should I call it, a loneliness factor activated. Okay, the shell of the iron atom will have the loneliness factor activated. What is the loneliness factor? It has a vibrational pull. Sorry, it has a non-vibrational pull energy factor. So it always want to be pulled towards something, and then because there is no more oxygen left outside of the planet Earth, then the other iron metal will basically see, okay, since my electron shell are not, what should I call it? Since my electron shell are not occupied by oxygen, let's bond together, and then they bond. Okay. So when I talk about, let's say, a box, box box, that is, I'm going to use a pump, 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 pump. So when I pump out all of the air, what actually happening is each of these layer of the surface of the atom of the glass that we see are basically saying, I am lonely, I am lonely, give me atom, give me atom. This is what they are basically saying. So in the vacuum area, if let's say about this part has been covered with one type of atom, the in between area here, this area is also going to be the saying the same thing. I am lonely, I am lonely, give me atom, give me atom. Okay. So what are these? Okay. This we call this vacuum, and space doesn't want to stay empty. Instead of saying space doesn't want to stay empty, we will be saying atom does not wants to be separated from another atom. Okay. So what we call vacuum, okay, is not basically the space has a certain pull energy. No. If we look for the pull energy, we must need to understand where is the pull going. Okay. For example, in the vacuum of space, let's say just outside of the earth, if a if an astronaut were to take off his shirt and commit self death, then what will happen is, he will, if he opens his clothes, then all of the atom will go back to the earth. Okay, because that is where the vacuum pull is the highest. Okay, what is the vacuum pull then? You might not believe this, but vacuum pull is equivalent to saying a magnetic pull similar to that of a gravitational pull. It is, this is fucking annoying because, as I already said, the earth has a stacking system, the gravity has a stacking system. The heaviest atom will be on the lowest, then the top atom will be highest, and something like this. How can I prove it? In order to prove this, I should have told about this topic a bit later in the my 10 dimension. That is, in the 10 dimension, I basically gave it a name, and that name is basically gravity density sorting factor. So in my 10D plus 10D, that is, I specifically told about how gravity as a sorting factor by which it sorts the atom in a following manner, which I already said before, like how, let's say this is the ground, and then each layer will basically have different types of atom to them, and on the topmost layer there is helium and hydrogen, and as we go down there, the heaviest atom can be found near the bottom area. Okay. So the reason we say that the vacuum box is basically just a pressure box. Okay, what is constitute as pressure, or like what is pressure? Pressure, pressure. Like what type of pressure are we talking about? Are we talking about push pressure, like a hydraulic press pushing and breaking the brick? Are we talking about this pressure? Are we talking about vacuum pressure? Are we talking about the vacuum pressure? If we talk about vacuum pressure, then vacuum pressure is basically like the internal of the box is, once it is empty, it is saying we do not want to stay empty, give us the atoms back. And as the atoms enter this place, once the fulfillment has been covered, then what will happen is they will not be sucking anything anymore. The same logic applies to the vacuum of Earth also. If this person who is outside of the planet Earth, okay, takes off his or her clothes, then where do you think the atoms are gonna go? The atoms are gonna go back to the Earth. Okay, this is the complicated part. Like people are gonna say, people are gonna say that the pull of magnetism and gravity are separate. Gravity and magnetism are separate. Okay, let's say you are right. Gravity and magnetism is separate. The Curie motor effect. Then how does this work? Right? I already explained. I do not need to explain again. How does that work? Think like that. Okay. Now another thing is the following one, which is molecular path averaging interaction. Okay, I think this is cloud chamber. Quantum cloud chamber system like cloud chamber observed particle track nonlinear. It shouldn't be here. Why is this here? Thermodynamic invisibility field. Okay, this is the one that I have already explained about the magnet. So overall, what does it mean? Overall, I will say our understanding of the atom is incorrect. Okay, atom has two type of signal. Atom has two type of signal. Atom has two type of signal. Okay, a pull signal. A pull signal. It is completely thermodynamically thermodynamically invisible. It is fully thermodynamically invisible, and the push signal is thermodynamically visible. Push push signal is thermodynamically visible. So this is the whole difference. This is what I am saying, and uh, this is mostly about the path averaging. But I had to talk about the uh, 10 dimension 10 and 12 and 13 a little bit, as otherwise you would not be able to understand it. I'm sorry about that. Okay, so if you find today's topic a little bit disturbing, then please let me know in the comment section. You do not need to let me know. I already know I have fucked up here, because I have never fall into the category of trying to explain something to someone I know myself very well, but trying to explain it to another person is going to be this much difficult. Okay, so goodbye, stay safe, and see you again next time.